Okay, this next section is section 4.4 where we're graphing a function rule. So hopefully by the end of this section you can say I can graph equations that represent functions. So this is something that we should have seen before. We're simply going to take an equation, we're going to make a t-chart for it, and then we're going to use that to make a graph. So for instance, if the first one is a negative 2x plus 1, to build my t-chart, I'm simply going to replace the x with the values that we have for the x. So in this case, I'd have y is equal to a negative 2 times a negative 1 plus a 1. So if I evaluate that, I get a positive 2 here, plus 1 would be a 3. So my ordered pair would be a negative 1, 3. Next one, if I put in a negative or a 0 for the x, this here is going to give me 0, plus 1 is going to be 1, so my ordered pair would be 0, 1. And the next one, if you plug in a 1, you'd have negative 2 times a 1 plus a 1, so this is a negative 2 plus 1 is going to give me a negative 1. So my ordered pair would be a 1, negative 1. If you plug in a 2, I'd have a negative 2 times a 2 plus a 1, so this is going to be a negative 4 plus a 1 is going to give me a negative 3, so my ordered pair would be 2, negative 3. And then I just come over here and graph those points. So I got a negative 1, 3. I've got 0, 1. I've got a 1, negative 1. I've got a 2, negative 3. And I would connect my points, and I'd have this nice, neat graph. Okay. So same idea on this next one. I've got 1 half x minus 1. So I'd have a 1 half times a negative 1 minus 1. So this is going to give me a negative 1 half minus 1 is going to be a negative 1 and a half. So my ordered pair would be a negative 1, negative 1 and a half. Okay, if I plug in a 0, I'd have 1 half times a 0 minus 1. Again, this is going to be a 0 minus 1 is a negative 1. So my ordered pair would be 0, negative 1. If I plug in a 1, I'd have 1 half times a 1 minus a 1. So this is going to be a 1 half minus 1 is a negative 1 half. So my ordered pair would be a 1, negative 1 half. And the last one, if I put in a 2, I'd have 1 half times a 2 minus 1. So half of 2 is 1. Minus 1 is going to give me 0. So I'd have 2, 0. And when I come to graph them, I'd have a negative 1, negative 1 and a half. So that'd be this point here. I'd have a 0, negative 1. I'd have a 1, negative a half. I'd have a 2, 0. So I'd have those points in that line as a result. Okay. Next one, same idea, now only with a more of a word problem. So the function W equals 146C plus 30,000 represents the total weight W in pounds of concrete mixer truck that carries C cubic feet of concrete. If the capacity of the truck is 200 cubic feet, what is the reasonable graph of the function rule? So for this one, we're going to do the same sort of thing that we were going to be doing. 146 C plus 30,000. So one thing that we should think about is independent dependent variables. So the independent variable is the capacity or the cubic feet of mix that is going to be in this truck. So our independent variable is here. Our dependent, the weight, depends on how much capacity we have or how many cubic feet we have in here. So the reasonable graphs would start at 0 for this one because we can't think of capacity as being negatives. So if we put in a 0 in this one, we would have 146 times a 0 plus 30,000. So our ordered pair would be 0, 30,000. Okay, which means if you have no concrete mix in here, your truck still weighs 30,000 pounds. So next one we put in a 50. So if I take 146 times 50, I get 73,000 or 7,300 plus 30,000. That's going to take us to 37,300. So I'd have 0 and then 37,300. Okay, if I put in 100 cubic feet, so then I'm going to have 10,000, or excuse me, 14,600 plus 30,000, which is going to give me 44,600. So sorry, this should have been a 50 here. This is going to be at 100 cubic feet. You are going to have 44,600 pounds. Okay, this 50 is bothering me. Let me change that here. Okay. So now, if I put in 150, if I put in 150, I'd have 146 times 150 plus 30,000. And 146 times 150 gives me 21,900 plus the 30,000 is going to give me 51,900. So I'd have the ordered pair 150, 51,900. And the last one I put in 200. So my cubic feet of 200 cubic feet. And when I calculate this one, 146 times 200 gives me 29,200 plus the 30,000 that are already in there gives me 59,200. Okay, so that would be 200 and then 59,200. So the maximum capacity was 200 cubic feet. So now the maximum weight on my truck would be 59,200 pounds. So if I'm going to make the graph of this, I'm going to have my capacity down here and my weight over here. So I know that I increased my weights by 50, or my capacities by 50, so I'm going to go 50, 100, 150, 200. Okay, and then my weights, I'm going to have to make a scale over here, so I'm going to go by 20,000s. Let's make it 5,000s. So this would be a 10,000. This would be 20,000. This would be 30,000. This would be 40,000. This would be 50,000. And this would be 60,000. So if I look back at my first one, I had 0 and 30,000. So 0, 30,000. So I got 1 point right here. And then I have 50 and 37,300. 50, 37,300. And then I have 100 and 44,600. 44,600. And then I've got 150, 51,900. And then I have 200 and 59,200. So this again would be a linear function because it graphs out to be a nice neat line. Okay. Here's another example. Okay, so the farmers sorry, I was looking for one other thing. Okay, so this one, a local cheesemaker is making cheese to sell. We want to know if it's going to be the amount of milk is used to make cheese and the price in which he sells the cheese is shown. Write a function for each situation. Graph each function. Is the graph continuous or discrete? So if we take a look at this one, milk, a gallon of milk makes 16 ounces of cheese. So the weight of the cheese in ounces depends on the number of gallons of milk. So we have this function, W is equal to 16M. So if I were to make a table of the values, if I made a table of values, if I made a table of values, I could get this table. The weight of cheese in ounces depends on the number of gallons of milk. So you'd get this table, which then translates to this equation or this graph. So the weight of cheese and milk in gallons determined by determining the weight of the cheese. So the amount of milk makes sense to connect the points because the graph is continuous, which means continuous means that I can have 1.5 gallons or a half a gallon or 32.6 ounces. It makes sense to have continuous data. Okay, on the other hand, the amount of money made by selling the cheese depends on number of wheels because if we look up here, the wheel of cheddar costs $9. So the value we got here is A is equal to 9N. So my table of values would look like so. So I've got my table of values, which then translates into this graph. And the graph would only be dots because you're not going to cut up your wheel of cheese into infinitely many different sizes. So it's either going to cost nothing for nothing. If you buy one, it's going to cost $9. Two is going to cost 18. Three is going to cost 27. Four is going to cost 36. So we would sell whole wheels of cheese. So we would say that this is a discrete function. Discrete versus continuous. Continuous forms a solid line. Discrete is simply separate points. Okay, so the next one, if we just think about these, trying to decide whether they're continuous or discrete, we're not going to graph them, but if we just kind of thought through these, so the first one, the amount of water W in a wading pool in gallons depends on the amount of time in minutes the wading pool is filling as related to this function. So what do we think about? We're thinking about gallons, and we're thinking about time. So if we're thinking about gallons and time, gallons can be broken down into infinitely many parts as well as the number of minutes. Okay, if I looked at the next one, so this one would be an example, again, gallons and time. This is an example of a continuous. Continuous. Oh boy. So the first one is continuous. The second one, the cost C for the baseball tickets in dollars depends on the number of tickets bought. So if we're talking about tickets in dollars, tickets compared to dollars, this one we would have to say is discrete because we cannot be selling a half a ticket or 1.5 tickets. So this one would be a discrete example. Okay, I'm sorry for the technical issues there. I was just trying some different things, but hopefully we got through that okay. So that is a wrap.